All right, let's get started. We are doing our second review day today, which is our first day of practice questions. This is all pre-midterm material, and then on Thursday we will do post-midterm material. So I will wait there. I'll give you a practice question and about 2 minutes or so, 2 or 3 minutes to try to solve it, and then we'll look at the answer, and then we'll move on to the next question. Pretty simple structure. Good morning. These are the ones that I have set up. These slides are posted already. So in the previous classes, I didn't have time to get to number 8 here, but you can look at that on the slides and try that on your own if you'd like. Make sure my phone is muted. There. So this is the plan. Start with some easy stuff and then get to some slightly harder stuff. Okay, first one's here. Read it and try to get a solution. All right, that's been 2 minutes. Tell me what we can do. Okay, slope between these two. How do we find slope? All right, delta y over delta x. Which point seems easier to be kind of 0.2 or 0.1? It doesn't matter. What was your choice? B as A minus B. Okay, so this is our sort of 2. This is our 0.1. All right, our delta y is 5 minus 1, so 4. And our delta x is 4 minus 6, negative. And negative 2 over 5 or negative 0.4. What's next? All right, so we have our slope here, negative 0.4x plus b. We don't know what b is, so we substitute in one of these points. Let's use this b here. So 1 equals negative 0.4x. Sorry, I forgot. X times 6 plus b. So b is equal to 3.4. Okay, So then we have our equation here, y equals negative 0.4 x plus 3.4. Part B, what are we doing? Partly, so if our slope of AB is what we said here, negative 2/5. Right, we want the perpendicular slope. So slope that's perpendicular to AB, which means we flip over the fraction, 5/2, and we also change the sign, in this case from negative to positive. So the negative reciprocal, their fancy words there. And then the exact same process. So y equals negative, or sorry, not negative, positive 2.5 x plus b1. We'll use point b again. So 1 equals 2.5 times 6 plus b, and b is equal to negative 14. And there's the equation. So y equals 2.5 x minus 14. Done. Right quickly. We're good? All right, next one. Go ahead. Two minutes. Okay, so this is a type of problem that we never did in class, but we can still use just our basic kind of equations and points and slope stuff to figure this out. Okay, so what's your strategy? Uh-huh. Uh-huh. Okay, so let me repeat that for everyone online. So we have two possible situations. Either all three of the lines, or sorry, all three of the points line up, or they don't appear on one line and we'd have to have two different lines. So do they all line up? So one method is we can just look at the equation, build an equation from two of the points, and then just check, is the third point on that line? And then it works. Another method is we could take 2 points and then another 2 points and find the slopes in each case. And if the slopes are different, then they must not line up. If the slopes are the same, then they do line up. All right, so let's do that. Which points did you choose to work this out? P and Q. All right. So let's do P is kind of 2 and Q is 1. So our slope delta y here is 6 minus 0, so 6. And our delta x, 9 minus -1, so that's 10. So 3/5 or 0.6. Okay. And then our equation, y equals 0.6 x plus b. Substitute in point q. That looks very easy to work with. -1 is equal to 0.6 times 0 plus. Sorry. Yeah, substitute. Yeah, wrong spot. Try that again. 0 is equal to -6. 0.6 times -1 plus b. So b is also equal to 0.6. So there's the first equation, y equals 0.6 x plus 0.6. And then we just substitute in our values from point R here. So it would have to be true that -5 is equal to 0.6 times -9 plus 0.6. All right, right side 0.6 times -9. All right, -5.4 plus 0.6. So this is saying that -5 is equal to -4.8. And that's obviously not true. So they do line up or they don't line up. They don't line up. Impossible result. So not on the line. R is not on PQ, therefore not collinear. Okay, so a few different ways we can use this. This does require a little bit of sort of some math creativity to try to see how we could use our simple tools to solve this, but ultimately not too tricky. We're ready? All right, next one. Go ahead. All right, 2 minutes. What do you think the solution is? And what does that mean? Okay, so we're saying that there's no intersection point. Okay, so they might be parallel. All right, so let's look. What did you do to try to figure this out? Okay, so we common factor of G, sorry, in G of 4. So 12x plus 28y equals 12. We can simplify this to 3x plus common factor, sorry, wrong, 28. Right there. So 7y equals 3. All right, and what else? What's the common factor? Okay, so H, we say we hate fractions, so no more fractions. Let's multiply by something to get rid of all those. What are we multiplying by? 21. So just this, our lowest common multiple here. Equals 63. Okay, at this point, we kind of have enough information to get our solution. But if we want to be really thorough here, we could try to do our elimination. And y equals 63. And subtract. And then we realize, oh, that's 0, that's 0, and this is just not 0 on the other side, so that doesn't work. So there's no point of intersection. At this stage, we do have enough to find it. Slopes in our standard form, ax plus by equals c. I don't know if I talked about this in class, but we definitely talked about it in a workshop. What's the slope? Not just a. Imagine if you rearrange this, we'd have like by is equal to negative ax plus c. Divide both sides by b. Negative a over b. So that's our slope. So basically these two numbers here, if these two coefficients are the same, we have the same slope. And the constant is not, it's going to come from this thing here. Same slope, different constant, that means it's parallel. So that's already enough information, but we can kind of show it very clearly with our elimination there. They are parallel. Yeah, that's the relationship. So parallel, so no point of intersection. Parallel, therefore, no intersection. Good. All right, next one. Oh, all right. Take some time and read and see what you can do. Just read it. The math is not that hard in this question. You're done or you gave up? All right, that was 3 minutes. Let's see if we got a message in chat. We got a solution. All right, we'll come back and look at the solution, see if it's correct. What kind of problem is this? Break even. Break even. Fixed cost, revenue, cost, loss of this thing, which we can recognize is actually talking about a negative profit. Lots of clues here that this is a break-even problem. Okay, so break-even problems, what do we need? Total revenue, okay. What's our total revenue? 5Q. So the money that they're earning here, they get 5 won per order, 5 Korean won per order. It's a very small amount of money, but it's just like some digital app processing payment. So total revenue, 5Q. We need a total cost. Okay, good. So Q, so 1Q or just Q plus 1, and I'm just going to be lazy here, 1.2 billion. Not going to write all the zeros. Processing costs, 1 won per order. There's the variable cost, 1 won, and our fixed yearly costs, 1.2 billion. Yeah. All right. So what's next? Okay. So our profits equation. So profits, which is total revenue minus total cost, which will be 4Q minus 1.2 billion at the break-even points. All right. So 0 is 4Q minus 1.2 billion. So Q is equal to, I'll write it this way, 0.3 billion or 300 million, however we want to write it. All right. So there's how many orders in order to break even. We did that part, but they're also saying, what would the revenue be at that point? Okay, how are we finding that? All right. We just take our Q value, put it into our total revenue equation. So TR in that case is 5 times 0.3 billion, so 1.5 billion. While you're working on it, that's fine. At the very final stage, just give the kind of full version. All right, so that's A finished. What is B asking us to do? Okay, so how can we interpret that? What will we use with our equations here? Loss, a loss of whatever. How can we represent loss with our equation? Negative what? Negative profit. If you're losing money, that's negative profit, right? So in this case, we are trying to find the Q value that makes our profits negative, and we'll write it as billion just for convenience with this, negative 0.5 billion. So instead of 0 is equal to 4q minus 1.2, it's negative 0.5. So negative 0.5 billion is equal to 4q minus 1.2 billion. So 4q is equal to 0.7 billion. 0. Without the calculator. All right, so 0.175 billion. Just think 7 over 4, that's the same as 3.5 over 2, half of 3.5, 1.75, and just adjust for the zeros there. All right, so that is the Q, their minimum number of orders needed to hit this loss of that much money. And we could rewrite this here. So as our Q of 175000000, kind of write out the long way at the end there. If you use some short version while you're doing your calculations, that's fine. Questions? All right, it was really long, but this is not that bad. The math is not that bad. Just look for the clues, see what kind of question you have, look for the parts. Looks scary, but it actually wasn't that bad. In the real world, people don't hand you equations and just say, do the math. You have to make the equations on your own. So this is also a necessary skill. We're ready. Yeah. This one? So that's defined by the problem here. This Q is exactly 0 profit. This is the break-even point. But this one here is this. It's when we're losing 0.5 billion won or 500 million won. Most companies don't make money in their first year. They lose money in their first year. But there's like, if we lose this much money, this is okay. But if we lose more than that, we can't run the business. So this is the maximum loss they will accept. Yeah, like lots of companies, Uber for years ran at a loss. They lost money, but they didn't lose like $100 billion a year. They lost like some small amount. They were close to profit, close to profitable. So this is close, but not exactly profitable. All right. Next one. Okay, well, that was 2 minutes. So let's try to find all 4 of these. So we have 1, 2, 3, 4 things to find. So we'll just do them one by one. Number 1. X equals 1. So number one here. We're talking about this one here. Yeah. Okay, but these are inequalities. Okay, so just like we had when doing the other direction, when graphing inequalities, 3 steps. So first is the line. This line for number 1 is x equals 1. That's right. But now we have to do the inequality part. So are we shading on the right side or on the left side? Right side. Okay, so x greater than or equal to 1. So any x value can be larger than this. So shading on the right side, that's where our little shape there is. So on the right side, greater than or equal to 1. And then what was the final thing that we have to consider for inequalities? So the line, and then just the basic line, and then where you shade. And okay, so is the line itself included? So do we have a solid line or do we have a dashed line? These are all solid lines, so greater than or equal is the correct thing here. So we don't have to worry about that dash parts. Okay, so the first one, x is greater than or equal to 1. That's solved. Number 2. Right, y is greater than or equal to 1 because our shaded area is above that line, y equals 1. All right, number 3. One over 2 x plus 2. Like greater than or equal. Okay, I'll talk about that in a moment. There's still another problem with this. There's still a problem with this.
The slope is
Yeah,
negative.
negative slope. Negative slope here. So it's going down, negative slope. And we're shading above because here's the line, but the y values can be that, or they can be anything above that, so greater than or equal. If we're not certain about that, if we're not confident, we can always just pick any random point and test it in our inequality and then see what the direction is. And then that's the direction of the inequality. All right, one more. Y is less than or equal to negative 5 over 6 x plus 5. Okay, so the intercept of 5 there, that's pretty easy to see. And then we have another point here. Just look for the points that line up nicely on our grid. And let's match those two up. Between these 2 points, our slope is our delta y over delta x. Our delta y between these 2 points from 5 to 0, so negative 5, and our delta x is from 0 to 6, so positive 6. And there's our slope, negative 5 over 6. All right, So those four things together as a system make that shape that we see. Questions? Next, we're excited about more. All right, we're making good time. So next one is gonna take some time. Linear programming question. All right, so let's do the setup first. I'll give you 2 minutes, read it, try to do the setup. What are the 3 things that we need to set up these problems? All right, try to set up the problem. Okay, that's been 2 minutes, so let's talk about setup first. What are the 3 things that we need to set up before we can actually start solving? Variables, okay. Okay, and okay, so can we choose how many tourists? Can we choose how many pieces of luggage? Doesn't work. Different variables. Variables have to be variable. Boats? Okay, so the 2 kinds of boats. We get to choose how many of each boat. That thing is variable. It can change, so those are the variables. So let's just use M for motorboats and P for pontoon boats. What's the next thing we need to set up? Constraints, okay. Constraints. All right, let's do the objective first. That's a bit easier. What is our objective? Not the equation yet, just what's the basic idea? That's how we would calculate it. What's the objective? What's the goal? Right, minimize cost. So minimize cost. And now we need an equation to calculate cost in terms of our 2 variables. What will that be? Cost. What's the cost? You're thinking constraints. Okay, so tell me as an equation. 60 m plus 60 p. So that's how much money it costs. We have to pay $60 for each motorboat, $60 for each pontoon boat. That will give us the total cost. There's our objective function. All right, constraints. What constraints do we have? That's a way of categorizing them, but what are the actual things? Okay, tell me the things that are constraints, and then we'll make the inequalities after. Okay, so number of people. So there's a people constraint here, and what's our inequality going to be? 4m plus 6p. Okay, 120. So here. So motorboats, each motorboat can carry 4 people, so 4 times m. Each pontoon boat can carry 6 people, and so 6 times p, and we have 120 people. Let's think about our inequality here. So less than or equal. Okay, so we're running some tour company here. We're trying to transport a whole bunch of tourists to some island. If we have capacity to transport exactly 120 people, that's fine. If we have capacity to transport 110 people, and we just pick 10 random people and say, sorry, you stay here. Is that okay? They're all going to be angry. They're going to demand refunds. So this is a minimum. We need to have capacity for at least 120 people. If it's more, then we have to spend a bit extra money, but that's okay. But we have to transport all the people. So that is a minimum. If 120 is a minimum. So this is a minimum cost problem. If it was 120 as a maximum, then there's no minimum, and then we just do 0, transport nobody, and we spend no money. But that's not really a meaningful problem, right? So it wouldn't be that. So this people constraint is forcing our cost up, but despite that, we want to find the lowest possible. Okay, next constraint. Tell me the thing first, then tell me the inequality. Okay, luggage, which I wrote as cargo here, so I'll write it that way. Cargo, which is 8m plus 6p greater than or equal to 180. Okay, so same idea as the previous one. One more constraint. Okay, 14 pontoon boats available. Okay, so not equal. Greater than or less than? Less than or equal to 14. We only have 14 available. If p is less than 14, that's fine, but we can't go over 14 because there just aren't that many available. All right, so there's variables, constraints, and objective. So next part. This was a more complicated question. This was from I think a midterm from like a year ago or something. So I gave the students this graph on the exam because the question was more complicated. So let's look at the graph. We have lots of regions here. So which thing is actually the feasible region? There could be that one, or 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 that one. So look think about it, then tell me which one is the feasible region for this problem. Look very carefully at the constraints and the directions of them. Take a moment to think, and then I'll ask. Okay. Tell me which one you think. Tell me which one you think it is. What number? You say 6? Why 6?
No, I think it's either 1 or 2.
Okay, why 1 or why 2?
Nine.
Okay, don't get tricked by like, oh, the shapes normally look like this. Read the inequalities carefully. So, okay. Let's just work on this kind of process of elimination just one by one. Let's start with the easiest one here. P is less than or equal to 14. So here's our pontoon line, right? Less than or equal to 14. So below or above? Below. Okay, so things below are possible, things above are not possible. Okay, so we've eliminated that. Next one, cargo. Here's our cargo line in, or let's not do that one. Next, let's do people next. Here's our people constraints. Are we above or below that line? We are above this line. Okay, so 2, 4, 7 are not possible. Okay, now we can see the 9. We are above the cargo constraint, and it must be 9. So don't get fooled by those like, oh, well, the other questions had this kind of shape. Look at the inequalities carefully. This is the feasible region here. There's our feasible region. So corners then are 1, 2, and 3. Those are the possible corners here. Which one looks like the best corner? Sorry, I should number these. Let's call this A, B, and C. B, why B? Okay, so B is closest to our objective function here, this point. C is far away. We can see that the orange and green lines, as we go down, they're getting closer. So as we go up, they're getting farther away. So automatically that means A must be further away than B because it's closer to the point where they meet. So there we go, it's B. And how do we find the exact coordinates for B? Right, so it's where these two constraints are meeting. Just find your point of intersection. We can work that out pretty easily. And it looks like on the graph, it's 10 and 15, I think, 10 and 14. 10 and 15, okay. So that would be our answer to A. And tight versus slack constraints. What does that part mean? Okay, so if we used all of that constraint, if we're at the limit, then the constraint is tight. If we are not at the limit, the constraint is slack. Which ones are tight? Which ones are slack? Okay, here, which ones? People, cargo, pontoon. Which ones are tight? Which ones are slack? You don't need to calculate. Just look at the graph. You should be able to answer right away. Just one? Okay, look at our points. What two things are meeting at this point? Okay, so we are at the limit of those things, right? So cargo is this and everything above. People is this and everything above. We can't go lower for cargo. We can't go lower for people. So wherever your best corner is, that point of intersection, whatever meets, those are the tight constraints. So people and cargo meet on our best corner. So those two are the tight constraints. And yeah, pontoon we can see is a slack constraint. We can see that in the graph also. Erase all this stuff. We can see that here too. Here's the limit for pontoon boats. Here's the actual corner we chose. They're not touching. They're slack. It's if this is 10, this is 14, then it's exactly 4 extra boats. So this one is slack. So the corner, whatever things meet at your best corner, those ones are tight, the other ones are slack. Ready? Next. Okay. Next one, matrices. All right. These take a bit of time to solve. I'll give you 2 minutes now. Tell me which ones are possible and not possible. Okay, work that out first. Possible or not possible? I don't understand Russian, but I can still understand what you're talking about. Transposing is not rotating, it's flipping. B? We'll talk about it in 30 seconds and then we'll talk about it. The order of operations, the multiplication is happening first, the subtraction is happening second. All right, let's talk about these. A, is A possible or not?
Yes.
We say possible. Okay, so A transpose, what will the dimensions be of A transpose?
2.
What are the dimensions of matrix A? 2 by 3. If we do a transpose, what will the size be? 3 by 2. 3 by 2. B here is also a 3 by 2 matrix. Same size, so that is very possible. B, A times B, is that possible? So A, we said, is a 2 by 3. B is a 3 by 2. What do we look at to know?
The number of rows of the first.
Columns of the first, rows of the second one. The inside numbers here. Inside numbers, those match 3 and 3. So yes, it's possible. How large will our result be? 2 by 2 from the outside numbers here. Okay, so this will produce a 2 by 2 matrix. C is a 2 by 2 matrix. So this is possible. Okay, we'll actually do the operation in a minute, but let's just talk through the other ones first. C here, possible or not? Why not? Okay, this is the A plus B here. A and B are not the same dimensions. That part does not work. The times I, that would be fine, but this part does not work, so that's not possible. D, we say possible. B transpose, what would the dimensions be? 2 by 3, and D is a 3 by 3. Inside numbers match, that's possible. And E, possible. C transpose is still a 2 by 2, and A is a 2 by 3. Inside numbers match. That's going to work. Okay, so C is not possible. The rest are possible. I'm just going to erase all this. Yes, yes, no, yes, yes. All right, so let's actually do these. What is A transpose?
The first column is 2 plus -3.
Okay, so there's A transpose. We want to add that to B. So I'm not going to rewrite B here just to save some time. So what's our result? -5, -6, 3, 7, and okay, so there we go. There's our result for A transpose plus B. Let's do the next one. A times B first. A is 2, -3, -1, -4, 2, 1. And B, 3, -2, 6, 5, -7, 1. Okay, so if we remember with our matrix multiplication, our way of lining these up to make it work, to make it easier to know what goes where. So we have 4 positions that we need to calculate. So first position up here will be the first row times the first column. 6 minus 18 plus 7. Okay. In the other classes, a bunch of people forgot, so I'll just remind everyone here. So these numbers it's 2 times the first thing times the first one. The second one times the second one, -3 times 6. Third one times the third one here. And then we just add all of them together. So 6 plus -18 plus 7, and that'll be our number. All right, next position here, tell me the 3 numbers. Minus. Okay. All right, and our next position here. -12 plus 12 minus 7. Plus 10 plus 1. All right. So let's just add all those parts together. What's our result? 5. 5. All right. Next. Yeah, -5. Okay. Oh. All right, thank you. All right, I forgot to write that negative, so then that's positive and that's negative. There. All right. So what are our 2 numbers here? 18 plus 1 and 17. Okay. I think that is all correct now from what I remember. Okay. And then we take this thing and we subtract C. So AB, we've already calculated, minus C. What will our result be? -2, -21, -7 minus 2, -9, and 17 minus -2, that looks like 19. Okay, so there's the first 2. Yeah, let's go on to D. I'm gonna have to erase this to make space. Everyone has this written down. All right, so I'm erasing. All right, B transpose, that's our next one. What is B transpose? 3, 6, -7. 5, -1. Okay, so there's our B transpose. We want to multiply that by 1/2 of D. So 1/2 times D would be equal to what? Oh, okay, so 2's on the main diagonal here, and the rest will all be 0 like this. What do you think will happen if we do B transpose times D? We could do the matrix multiplication thing, but there's a shorter way we can figure this out. Tell me how we could rewrite this thing using an identity matrix. What does an identity matrix look like? Okay, so 2 times a 3 by 3 identity matrix. That would give us 2, 2, 2 in the main diagonal. So, yeah. Okay, right. So if we do B transpose times 2 times an identity matrix, we could kind of split it up like this. It's the same thing happening. Yes. So B transpose times 2 and then times the identity matrix won't change anything. And that's just a shorter method. Okay. So the standard matrix multiplication thing we just did will work fine, but this is a shorter way. We can recognize that. So the result here would just be 6, 12, negative 14, and negative 4, 10, negative 2. Okay. So remember an identity matrix. Do you remember what that looks like? Yeah. So 1, 1, 1, 0, 0. So that's this. What if we did 2 times this identity matrix? Right, and everything else still 0. So this half of D, this thing here, that's equal to 2 times I, 2 times a 3 by 3 identity matrix. So we can just split that up. So that's all we're doing here. Let's just split up the 2 in the identity matrix and then just do the 2 first.
Like this metric, like the one that we have right now.
So we would do this operation, right? But multiplying by the identity matrix does nothing. So once we do B transpose times 2, we're done. So we just skip the identity matrix part because it doesn't do anything. It's just times 1. So shortcut method. We can, if we understand these properties of identity matrices, we can recognize that. C transpose times 3A, that's just more of the same stuff. I'm gonna skip over that one. Okay. Good. All right. Last one. I don't know if we have time to solve this, but we can do a little bit and just kind of review our row operations here. So this thing as a matrix, let's just talk through this together. Let's do it here. So as a matrix, what would our first row be? 3, 2, 4, 11. 2, negative 1, 3, 4. And 3, 5, negative 3, 5, negative 1. Okay, and we want, let's write it here. Dot, 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 dot. What is our intermediate shape? What's our intermediate process that what's halfway done? All right, our kind of triangle shape here. 1, 1, 1, something, 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 but then all zeros here and then something over here. So that would be halfway done. Okay, so if we were to start with this thing, what would you start with? What would your first operation be? So we probably want to kind of eliminate, and get a 1 in that first position. So what could we do? We row 2. 3 row 2 minus 2 row 1. Yeah. Okay, good. So we take this one times 3, which will give us a 6 in that position, and then minus 2 times row 1, also a 6. And if we subtract, that will eliminate, and we will get a 0 here, and then a bunch of stuff. Okay.
So,
3 times row 3 minus 5 times row 1, and that would give us a 15 for this position times 3, and a 15, 3 times 5 here, 15. So when we subtract those, that will also give us a 0 in this position, and a bunch of other stuff. So yeah, we don't have, I don't want to go over, so we don't have time to write all that out, but that's the first 2 row operations we would do. And then we would try to get, and then we could also, okay, the top position here, this opening one, this 3 in the very top left corner, we could reduce that to 1, but we'd get some not very nice fractions. Again, the main thing is eliminating. If we've eliminated these positions, then we're happy and just kind of move on to the next one. The next column, we can turn it into a 1 later when it gets easier. The main thing is eliminating, so do the easiest thing that lets you eliminate. Scaling it down can be later. So that's a strategy thing. Okay. All right, I'm going to leave that. You guys, the questions here, you can work it, do this for your own practice sometime later. All right. Any questions about the matrix stuff? We're starting at 7. So if you're coming in person, the room will be open around 6:40, 6:45 or so, to do all the setup and do attendance and all that stuff. And then actually starting from 7 o'clock to 9 o'clock. All right, in our next class, we will do post-midterm review. Fewer topics, but more formulas to try to remember. I have not posted the questions for that yet. I will do that. I should be able to do that later today. So if you want to look at them in advance and try them, then you can do that. Yeah, so one more review day. Hopefully this is going well for everyone. And just want to say, no one else was writing in the chat, but we saw Vincent had like all the right answers and also like quicker than everyone else too. Chat. Yeah, you can see all the right answers here. So he seems like he's very prepared for the exam. I hope other people are getting well prepared as well. All right, I'll see you all on Thursday, everyone.